When you're designing for reliability in the cloud, there are a couple of questions that come in mind, and one of them is whether I should go multi region or not. Under the reliability pillar of the well architected framework, there are scenarios that can help you achieve four nines of availability by just a single region setup. In order to go through multi-region scenarios, that too for your most business critical application needs, you can go multi-region, but that comes with its own set of complexities and operational overhead, which we are going to look in the following part of the video. In order to keep it simple, here are five core factors you should consider while you're making architecture decisions for meeting your business's resiliency requirements. Moving on, we're going to take an example of a corporate banking application and try to take some of the components we discussed earlier, the resilience components, and take design decisions upon different parts of this banking application. Okay, to begin with, let's start with the first pattern and let's call it P1, that is the multi-AZ. So P1 is essentially a cloud-based architecture pattern here that we are introducing in terms of availability zones deployed in an AWS region. Okay, so the P1 pattern here is using a multi-AZ setup where applications are operating across multi-AZ but within a single region. So you can see that an EC2 instance is being provisioned in one AZ, but the second AZ has like a backup EC2 instance situation deployed through an auto-scaling group. So use case that you can see in this pattern would be internal employee applications, right? Whether an internal employee is trying to look at internal think of is an internal employee's application, okay, which can sustain some amount of downtime, and it doesn't need to have multiple instances deployed because it's eventually a workforce that's trying to consume some of the internal resources. So in case your availability zone fails, the Amazon EC2 prompts an EC2 auto scaling group to recreate the application in another unaffected zone. Worst case, your internal employees might have to wait a little longer in order to access their application, as the EC2 instance is being spun up, which is typically few minutes. So the second pattern would be P2, that is multi-AZ deployment with static stability. P2 uses multiple instances here, unlike the first example, again deployed across multiple availability zones within a region to increase resilience. This pattern uses a concept called as static stability, and which eventually prevents bimodal behavior. It's different from the first pattern where we saw bimodal behavior in terms of an EC2 instance taking time to spin up in case it needs to be provisioned. Here you can already see two pre-provisioned EC2 instances. And this is exactly what statically stable system means. So static stability requires that your systems remain stable and operate in one mode, okay, irrespective of changes to the operating environment. There are really two concepts here. The first one is your user, while it's interacting with your application where your business logic lies, it is abstracted from the underlying working situation, right? So your users interact with your application through two layers. The first one being the control plane and the second one being the data plane concept. Okay, the control plane consists of all the interaction your user will have with your application, that is creating and updating your application. All crude operations would be carried out by a user through the control plane. The data plane sole purpose is to provide your business logic, and it really needs a high availability. It needs to be highly available and resilient. And that is the reason why we have to pre-provision resources under the concept of static stability. The key benefit of a statically stable system on AWS would be it reduces complexity of recovery during a disruption thanks to already pre-provisioned resources. So for example, if this AZ is going down, your availability zone health check group will ask it to divert traffic to this AZ, which is healthy. Okay. So again, thinking of the use cases from a banking application perspective would be a customer facing website wherein they require lower tolerance for downtime. You say a banking application or website needs to be highly available. It cannot afford any kind of downtime because it would result in loss of revenue. Because of this, your website say requires a minimum of 2 EC2 instances to be provisioned at any time, whether it's subject to AZ failure or whatever it is, whatever the reason. So that is why this kind of configuration will make sure you meet the typical business requirement, the business resilience requirements to be precise. Again, the trade-off you can see over here is the added cost. Where you need 2 EC2 instances, you're actually deploying for 200% capacity, right? So implementing P2 actually requires your application to support distributed operation across these multiple instances. So you can actually optimize. So if your application can actually support this pattern, where it can support distributed operation across multiple instances, you can deploy your workloads to all the available AZs, usually 3 or more. That's what I would recommend across the region, and say 3 AZs, and then you can deploy for 150% of your capacity across 3 AZs instead of this situation where you have deployed for 200%. That is 2x the capacity. So you save cost and also meet your business continuity requirement, and keep in mind your resiliency goals. Examples of single region and multi-AZ patterns throughout this video. I would like to highlight some of the important topics in order to think about reliability goals. For example, over here you can find example of implementation for availability goals based upon some of the core topics on which you can design for availability. So here you can see that in a single region and multi-AZ setup, you can design for up to 4 nines of availability. Okay, based upon these factors. Similarly, if you want to take your resiliency goals beyond 4 nines, that is say 5 nines of availability, there is multi-region design decisions that you need to take. I highly recommend giving the well-architected reliability pillar a read if you want to dive deep into some of the core concepts of reliability.